Okay, here I have an example of a three-dimensional shape that I need to find the volume for. Now this three-dimensional shape looks a lot like it's like some steps or something. And I could see this being a real-world problem in that if it wasn't dealing with meters, but if it was dealing with some other unit to measure, and if it was dealing with perhaps different values, I could see if somebody was going to pour some concrete steps on their property, and they were going to have to pay for somebody to bring in the concrete. They would probably want to know exactly how many cubic feet or a cubic measure of concrete they would need. So I see this as a very good example of a type of problem that people can encounter in their real lives. Now, when I have a shape like this and it wants me to find the volume of this three-dimensional figure, one of the things I'm going to do, because there's not really a formula to find the volume of a shape like this, but there is a formula for finding the volume of a rectangular prism. So what I'm going to do is convert this to rectangular prisms, and then I can find the volume of the rectangular prisms that make up the shape, add them together, and get my total volume. So looking at this, I think I'm going to make this be two rectangular prisms, and I'm going to split it this way. Now the reason I'm doing it that way is because right off the bat I can see some measurements that are going to make it very easy for me to find the volume. Now the formula that we have been using to find the volume, we've been using V equals length times width times height. Now we've also been using some other formulas, but the one that I'm going to be using in this situation is this one. This is the appropriate formula to use. Now I'm going to call this one rectangular prism A, and this one I'll call it rectangular prism B. And that's what I like to do whenever I have the same type of shape I'm working with. Now in this situation, for rectangular prism A, I'm going to say that volume equals, and the length on this, I'll say that I could say that this is the length. It looks like the height, but I could call that the length I wanted. I could say this is the length, but it looks like that could be the width, perhaps. If I look here, from this point to this point is 3 meters, so I know from this point to this point is 3 meters. So that could be the length. So I'll say 3 meters times, and I'll say 3.5 meters times 16 1/5 meters. 16 1/5. Now I'm going to go ahead and work this out. I'm going to work it out from left to right. Because of the commutative property of multiplication, I could move these around and multiply whichever factors, whichever values I want to first, and I'll still want it for the same product or the same volume. So if I have 3 times 3.5, I'm going to convert these to improper fractions. So I'm going to say 3, we'll work it out over here, 3 over 1 times, and then make this an improper fraction, this mixed number. 2 times 3 is 6 plus 1 is 7, 7 over 2. And that's going to give me 21, because 3 times 7 is 21, and that's going to be 21 halves, because 1 times 2 is 2. Now, I could convert this to a mixed number, but I'm going to have to multiply it by 13 1/5, so I'm just going to leave it like this because I'd have to convert it to an improper fraction anyhow. So 5 times 16, I know that 5 times 16 is going to give me 80. 80 plus 1 will be 81 over 5. Now, I cannot do any cross simplification or anything. These numbers are what we call relatively prime, so I'm going to just go ahead and multiply straight across. I'm going to start with this one here, 21 times 81. Well, if I have 20 and I times 81 by 20, I'm going to wind up with 162, I'm thinking. No, I'm sorry, that's completely wrong. I better work it out instead of trying to do it mentally. Breaking it apart, I'm going to go ahead and just work it on out. So 81 times 21, okay, 1, placeholder, 2, 16, 1, 3, 6, 1, okay. Alright, so 1,631. So that would be this part, 1,631 over, well, 2 times 5 is 10. Now I can convert this to an improper, to a mixed number. So I'll go ahead and do that. Now in the end, when I add it to the volume of rectangular prism B, I may have to convert it back to an improper fraction, but I'm going to go ahead and convert to a mixed number right now. And I know that I can get 163 and 1/10 meters cubed for the volume of rectangular prism A. So I'm going to go back to red. E equals 163 1/10 meters cubed. Now one thing I would like to notice is, let's see if it makes sense. Alright, I have 16 times, I'm just going to round it, 16 times 3, I could see that being about 45. And then 45 times 3, I could see that being about 150. So I can see with a half and a fifth, I can see that this is a realistic seeming value for my volume. Now, I'm going to use a different color. I'm going to use black. Let's find the area, the volume. We just got off a study of area, so sometimes I'm saying area. But I meant to say volume. Let's get the volume of rectangular prism B. So for B, I'm going to say volume equals length times width times height. And here I can count this is my length, this is my height, this is my width. So that's what I'll do. So 3 times, I'll tell you what I'm going to do. I want to multiply my whole numbers first. So I'll say 3 times 4 times 7 and 2/5. And like I said, it doesn't matter the order of your factors, you're still going to get the same product. Alright, volume equals 3 times 4 is 12, so 12 times 7 and 2/5. So let me go back to that blue to do my work. So let's see, 12 over 1 times 5 times 7 is 35 plus 2 is 37 over 5. Alright, 12 times 37, let's go ahead and work that out. 14, 7, placeholder, 7, 3, 4, 14, and 4. So 444 here. 1 times 5 is 5. Now, I can get out of here, let's see, since I'm going to have to wind up adding these together, I'm going to just leave it like an improper fraction here. I'm going to add this as an improper fraction. So I'm going to go ahead and leave it like this. Now let's change the end. I'll just go ahead and put up here though 4 over 5. Now I'm going to use a different color to add those volumes together. And I think I might clear me a little space here. Let's see. So I want to keep this up here. So 1,631 over 10. Okay, so let me clear a little space here to do some of my computation. Okay, so I'm going to say 100, let's see, 106.31 over 10 plus 444 over 5. I need like denominators, and the least common denominator for 10 and 5 will be 10. So 1631 over 10 plus 5 times 2 gives me 10, so 448 times 2 is 888. I'll add those together. Okay, and I'm going to use a calculator on this adding. I've got a calculator handy, so let's see, 1,631 plus 888 equals, and this is going to be a big number, 2,519 over 10. And to convert that to a mixed number, let's see, that's going to give me 200, so this is the volume of the whole thing. The volume of the whole thing is going to give me 251 and 9/10 meters cubed. And when I look at these values, it does make sense. It seems like that would be a good answer, and I'm pretty sure it is correct. So if I were to attach a math practice to this one, the first thing I did was I used what I know about finding the volume of rectangular prisms. And then out of my toolkit, I used the formulas for finding the volume of rectangular prisms. And then I just worked it out step by step. So, I hope that this demonstration will help others be able to find the volume of three-dimensional figures by breaking them into three-dimensional shapes that we're familiar with.